Now we are on section B and we have some 5 questions of 2 markers in this section. So let's begin with the first question. The first question here from the real number chapter, the question says that find the HCF of these numbers 480 and 720, but using prime factorization method. So as you know that we first need to prime factorize. So I started with the number say 480. I will factorize by 2 first. It's 2, 2 times, 4 times, 0 times, 2, 1, 2, 0 times, 2, 6 times, 0 times, 2, 30 times, 2, 15 times, then 3, 5 times, and 5, 1 times. Likewise, I'm going to do for 720 as well. So I can see this is 236, 360 times, 2, 180 times, with 2, this is 90 times, 245 times, with 3 now is 3, 15 times, and 3, 5 times, 5, 1 times. So now I'll first write down the prime factorization of this. I can see this is 2 raised to the power 1, 2, 3, 4, 5. That is 2 raised to the power 5, 3 raised to the power 1, and 5 raised to the power 1. Similarly, if I express 720 in terms of its prime factorization, it is 2 raised to the power 4, and this is 3 raised to the power 2, and 5 raised to the power 1. Now, for finding out the common factors, as you can see, between these two, we have 2 raised to the power 4 common. Between these, we have 3 raised to the power 1, and here 5 raised to the power 1. So therefore, we'll declare that the HCF of these numbers will be 2 raised to the power 4 into 3 raised to the power 1, that is 3 and 5 raised to the power 1. This is how much? 8. 8 into, no, that's 16, right? 16 into 3 is 48. 48 into 5. So half of 48, 24. That is 240 is the HCF for these. Now we'll continue with the OR part. So now OR part of 26, that is part B here. In this question, it says that HCF of these two numbers, if expressed in the form of this, if it is equal to this, then we have to find the value of M. So before we proceed with the what we have to get here, let's first find out the HCF of these two numbers. So we can write down the prime factorization of 85. So 85 is what divisible by 5, right? So this is how much? 17 times, and this is 17 being prime 1 time. Similarly, if I write is 238, 238. So if it's prime factorization, as you know, it's divisible by 2. This is 1 time, and 9 times. This is divisible by 7, 17 times. Am I right? Yeah, it is 17 1 time. Now, if I find out the HCF, the prime factorization of HCF is 5 into 17, and prime factorization of 238 is 2 into 7 into 17. Needless to say that here 17 is the only common factor, therefore HCF of these number is 17. Now they're asking that if the HCF is expressed like this, that means I'm going to replace the HCF with 17, which is equal to this, that is 85M minus 238. Now we have to get M, so I'll be isolating M, and the normal method, as you know, is to transpose 238 on the other side. This is 85 times M. Now we have to add, this is 8 plus 7, that is 15, carrying 1, 3 plus 1, 4, 1, 5, and then 2. And if I transpose this 85 on the other side, so first what I did, I added 17 with 238. to get 255, and that divided by 85 is equal to m. So you can see that this is divisible by 3 times. So we say that the value of m in this case is 3. And I think this is what we had to find out. Yes, we have to find the value of m, and that is equal to 3 in this case. The next is question number 22a part. There are two parts. By two parts is A and B is an or option. It says two dice are rolled together bearing the numbers this, that is 4, 6, 7, 9, 11, 12, not in standard dice. What is the probability that the product of these numbers is a not? So you can see that I have taken two dices with the number bearing as said. And you can even from the figure, you can figure out that there are altogether 16 observations, right? This into this, right? Over. They're not this into this. If I say this with this, it will give you 4. Now, let's come back to the question here. We are given these numbers on the dice and we have to find their product being odd. So when do we get the product as odd? Like if I multiply these two, I'm getting 16. Similarly, if I take one even, another odd, I'm getting what? 28. That's again even. So when do we get an odd? When both the numbers are odd, like 7 into 7. So we'll whatever it comes here will be an odd. Similarly, 7 into 9 will give you how much? An odd number. We don't have to calculate the number. Similarly, when I multiply 7 with 11, I'm going to get an odd here. Likewise, if I multiply 9 with 7 and or 9 with 9, 9 with 11, these are the odd numbers over here. And with 11, again, if I multiply these, any of them, we are going to get odd. So you can check here that we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So the favorable observation is how much? Favorable observation is 9, and the total observation as I counted as 36, like 6 into 6, that is 36. So we can say that the required probability, let's say if I take PA will be the number of favorable observation, which is 9 divided by the total number of observation, 36. So if I reduce it, it's going to be 1 over 4. The B part for the same question, it says that how many 3-digit positive integers, how many positive 3-digit integers with 100 digit as 8 and the unit digit as 5. Okay. Find the probability of selecting one such number out of all 3-digit number. Now, let's say if I talk about the 3-digit number here, the smallest 3-digit number is what? Is 100, and the largest is 999. So in order to find out how many numbers are there, including both of this, the rule is that you should get the difference of these two, which is how much? 899, and should add 1 because both are included. If both are not included, then we subtract 1 from here. So altogether, counting from 100 to 99, we have 900 such numbers. But then if you look into this, like say, for example, if I make slots for here, this being the place for the 100th, 10th, and this is for the unit digit, or we can say ones digit. Now you see that we have to take this as 100 digit must be 8, so it is 8. And we have to place this, the unit digit has to be 5. So it can be what? It can be 805, likewise 815, like 825, and we count on like that till we get 895. So from 0 to 9, that is 10 such numbers will be there. You can even count it. So the favorable observation, like if I say the probability here, as you know that it is equal to the number of favorable observation, which I've counted here as 10 of them, and the total number of observation is 900. So if I reduce it, I'll get what? 1 over 9 as the required probability. Well, this is 1 over 90, not 9. So you need to write down the statement here. In the exam, you must write down that the formula here, that the required probability is the number of favorable observation divided by total number of observation. We are now on question number 23 of this sample paper. It says evaluate 2 sine square 60 minus tan square 30 over sec square. So if you remember the table, this should be a very easy. Like, what is tan 60? The value of tan 60 is root 3 by 2. Yeah, that's root 3 by 2. So it's root 3 by 2 whole square. I replace this tan 60 with this minus tan square 30. And tan square 30 is what? 1 over root 3. So 1 over root 3 square as this tan square. Sec 45, cos 45 is, yeah, cos 45 is 1 over root 2. So its reciprocal is root 2. So it's again root 2 square. Now for further simplification, what we can see, this is 2 multiplied root 3 square is 3 and 2 square is 4 minus 1 root 3 square is 3 and that divided by root 2 square, which is 2. I can see this gets reduced here by 2 times. So we have 3 over 2 minus 1 over 3, that whole divided by 2. Now, if I take LCM here, it's going to be LCM is what? LCM is going to be 6. This is 9 times minus 1, 2 times. And dividing by 2 is same as multiplying with its reciprocal. So this is, this is 2 times. So 9 minus 2 is 7. 7 over 6, that multiplied by 1 over 2, that is 7 over 12. So the answer for this is 7 over 12. We reach to question number 24 of this sample paper. It says, find the points on the x-axis which is at a distance of 41 units from this point. Now, we know that any point on the x-axis is in the form of x comma 0, right? The y-coordinate is 0. Any point on the x-axis, as you know that any point, if I take throughout this x-axis, here y-coordinate is 0. So we can say let the required point here, I took let the required point, let the required point be P whose coordinate is x comma 0. As you know that its y-coordinate will be 0. And say this is point Q, I took this point as Q. I'll write it here. Q is equal to 8 minus 5. We are given the distance between these 2 points PQ, which is equal to under root 41. Now, instead of applying the distance formula, let's first find out the square of this. This way we can minimize the calculation involved. Square of this, squaring both sides, we get this. Now applying distance formula, and I'll not be placing under root, as you know, I placed a square here. So it's x2 minus x1 whole square plus y2 minus y1 whole square is equal to 41. Next, I'm going to replace x2 and x1. Let's say I take this as 2, and there is no as such order that this always should be taken as 1, this as 2. I prefer to take variable as the first. So I replace x2 here. I'm replacing x2 with x. So this is x2 minus x1 whole square. That comes out to be x minus 8 whole square plus y2 minus y1 whole square. That will be 0 minus 5 whole square is equal to 41. Now for further working, what you can see that this is this will be as it is, say x minus 2 whole square, and this is how much? 5 square, which is 25. And if I transpose 25 on the other side, it is x minus 8 whole square is equal to, this will be 16. And x minus 8 is not 4, it is plus minus 4, as we are dealing with the coordinate geometry where the coordinate can be positive or negative. So now finally we will have two values. Now if I equate, I can say x minus 8 is either equal to 4 or x minus 8 is equal to minus 4. From here, what do we get? X is equal to, if I transpose minus 8 to the other side, we'll say x is 12. And if I transpose this, it's going to be minus 4 plus 8, that is equal to 4 here. Now check here, most of you actually end the answer over here. You lose marks because we have to find the coordinate here, right? We have to find the points, and the points is denoted by coordinate. So the required point which I took as x should be 12, comma 0, right? 12, 0, or it's what? 4, right? Next, replacing x with 4 here, it's 4, 0. So these are the 2 points on the x-axis whose distance from 8, 5 is 41 unit. In question number 25, we have to show that these points are the vertices of a triangle, of an isosceles triangle. So you know that in an isosceles triangle, two of its sides are equal, any two of its sides. So let's say I took these sides. As of now, I do not know which two sides are equal. So we may have to modify the figure later on. So let's say instead of naming these points, we can first find out the length of these sides. Like the sides has to be AB, BC, and AC. So I'm applying the distance formula. As you know, distance formula is what? It is x2 minus x1 whole square plus y2 minus y1 whole square. So let's say if I get the length of AB, say this is 2 and this is 1. So x2 minus x1, that is 3 minus minus 5, right? That's why I'm placing a plus sign. Plus y2 minus y1 whole square, that is 0 minus 6 whole square. So now AB comes out to be what? This is 3 plus 5 is 8. 8 square is 64. And 0 minus 6 is 6, but minus 6 whole square is positive 36. That means we get AB as under root 100, right? And you can directly write AB as 10 only, not plus minus 10, and is it as distance. Now we obtain AB. Let's say if I obtain the next side, that is BC here. To get BC, what we are going to get here from here to here, right? So that is x2 minus x1 whole square. That is 9 minus 3, which is 6. So this is 6 whole square. I may write 36 plus 8 minus 0. 8 minus 0 is 8. 8 square is 64. So BC is equal to under root 100. Now this implies that BC is 10 again. Well, ordinarily one can leave the answer over here only, because if two sides are equal, irrespective of its third side, whether equal or not, will be an isosceles triangle. But most of you say it's contradictory to what I said. Whenever three sides are equal, it is an equilateral triangle. But at the same time, it is an isosceles. So all isosceles triangles are not equilateral, but all equilateral triangle are isosceles. Now let's figure out the third side here has to be what? AC here. And applying the same way, the distance formula, that is x2 minus x1. So 9 minus minus 5 is 9 plus 5, which is 14, 14 square. And then it is 8 minus 6, which is 8 minus 6 is 2, 2 square. So 14 square is how much? 196. This is 196 plus 4. So AC is what? 200. I can split AC as 100 into 2, right? I can write AC as 100 into 2, and square root of 100 is 10. So it's 10 root 2. So as I said, irrespective whether you show this or not, we have shown here that two of its sides, AB and BC, are equal, considering this is AB. It says AB and BC, so it has to be B. Well, diagram is not necessary, just you to visualize. That is AB is equal to BC. So we said since two sides are equal, that's therefore these are the vertices of an isosceles triangle.